Good morning, students. Today we are going to discuss about the second part of the transistor. In the last class, we discussed about the invention of the transistor, importance of the transistor, how the transistor is forming, what are the basic terminals are there in the transistor, transistor operation, types of transistors we discussed. So basically what we discussed is transistors are two types, that is BJT and FET, bipolar junction transistor, field effect transistor. In the bipolar junction transistor we have again two types are there, NPN transistor, PNP transistor. So we discussed about the BJT, bipolar junction transistor. So the transistor having the three terminals, emitter, base, collector. Emitter is highly doped and the size is moderate. Coming to the base is lightly doped, then size is very thin, and collector is the moderately doped and the size is bigger than the emitter comparatively. So these are the three terminals. We applied the biasing, that is called active biasing. So we having the three terminals in the transistor and three layers we have, PNP or NPN, three layers, and we have the two junction, that is called emitter base junction is called as a emitter junction. Collector base junction is called as a collector junction. Emitter junction is in the forward bias and collector junction in the reverse bias. So this type of biasing is called as a active biasing. Biasing means applying the external DC voltage to the device is called as the biasing. So in the last class we discussed, if we apply the active biasing, how the free charge carriers are moving from the emitter to the collector through the base. Base here acts as a only carrier. Base here is acting as a only carrier. So now we further discuss about the transistor. In the today's class, we try to discuss some more topics about the transistor. As already we discussed, the transistor can perform number of other functions. Its main use lies in a amplifying electrical signal. Amplifying the electrical signal, that is called as a amplifier. The transistor also used as a switch, and transistors are also used as the impedance matching device, and another one is the transistor also used as the amplifier. The main application is amplification of the signal. So generally this is used in the communications. Whatever our transferred signal is there, the transferred signal is strengthened by passing through the amplifier. So before going to the amplifier, we try to know, we having the three terminals are there. In how many ways we can connect this transistor, in what way we need to give the input, in what way we need to take the output, we should know. So in which terminals we should give, we have the three terminals. So how we can give the signal? So the simple thing is, what we are doing is, this type of connectioning is called as a configuration. That is called as a transistor configuration. Transistor configuration means, so how the terminals we are utilizing. Here the main concept is, one terminal is used as a common for input and common for output. That is called as a common terminal. If we use the base as a common base. If we use the collector as a common collector. If we use the emitter as a common, that is called as a common emitter. So the device having the two input terminals, two output terminals, that is one is the common for both. So it is act as a common for input and common for output. So what we need to know is in these three connection, which connection is better for which application. So what type of connection we need to use, in which connection we are getting the our required amount of satisfied applications, amount of efficiency, or whatever it may be, our required parameter, which connection is meeting, that connection we are going to use. Now we try to discuss the which configuration having the more advantages compared to the other configurations, and how these connections are connected, and how the input and outputs are taken. Now let's discuss about these three configurations. Now you see we are generally used as the NPN transistor. So that is generally why, because NPN having the directions are common directions are as the conventional direction. NPN, the transistor direction is P to N. On the emitter it indicated by the arrow. In the figure you can see. So P to N, the arrow is there. In that way we having the current direction. You can see the NPN transistor connected in common base configuration. He given what happened is the common base configuration. So the what we are doing is the base is common for the input and output. You can see the three terminals are extended: emitter, base, collector. So the base is common for the input and output. You can see. So that is the VEE and VCC are the biased voltages to make the transistor in the active biasing condition. Why this active biasing means? Transistor can operate in three ways. First one is the that is called as a saturation. Second one is the active. Third one is the cutoff region. Three regions are there. The three regions depends on the junction biasing only. Saturation means if the emitter junction and collector junction both are forward bias, so that condition is called as the saturation condition, and it is nothing but an on condition. It acts as a short circuit at this place. Second one, as we know, that active region, that is the active biasing. So emitter junction is forward bias, collector junction is reverse bias. So this is called as a active biasing. So what happened in the active biasing means here the amount of free charge carriers are increases at the collector. So that is called as, it is used for the amplification purpose. And the last one is the cutoff region. That is if both the junctions are reverse bias, the both the means emitter junction and collector junction, both the junctions are reverse bias, then the device will be off. So generally the active region is used for the amplification purpose. The saturation and cutoff, both the regions combinedly used for the switching purposes. The meaning is the transistor can operate as a switch. If you switch the supply voltage in between saturation region and cutoff region, then it is act as a switch. So now you see that is the VEE and VCC is the biasing voltages. Emitter, base, collector terminals are there, and we indicated the direction of current. You see here arrow arrow indicate the how the current is flowing, conventional current, that is IE outwards, IE, and IC inwards, and IB is inwards, that is IE equal to IB plus IC generally. So the input side, you can see what they are using is they applied the weak signal. This is for the understanding purpose, given weak signal. The outside you can see they applied the load. So like this connection is their amplifier connection. This is the common base. We apply the weak signal. That weak signal is amplified. That is given as and taken that signal at the load. This is a common base configuration. So we see the common base configuration amplifier with input and output waveform. You can see how it is like that. So we applied the input radio signal is weak, that is the sound signal. So the output voltage is the amplified. You can see like that. You see the represented with transistor physical diagram with this one. You can see the diagram. So what happened once we try to see the input signal Vs is applied is between emitter and base, that is the emitter junction, and the output signal is appears between collector and base, that is across the collector junction. The transistor is biased to operate in the active region. The transistor is biased to operate in the active region. Emitter junction is forward biased by VEE and collector junction is reverse biased by VCC, as I already mentioned. Emitter junction is forward biased by VEE and the collector junction is reverse biased by VCC. So the input resistance of the transistor in low and output resistance is high. Input resistance is low, output resistance is high. When input signal is not applied, a DC IC will flow in the collector circuit due to VEE and a constant output VDC is developed across the load resistor RL. The meaning is without applying the supply signal, what happened means VEE produces some DC and that DC voltage appear across the output load, that is across the RL. So when the input signal is superimposed on the DC voltage, if it's superimposed on the DC voltage, a small change in signal voltage causes an appreciable change in the IE because of the low resistance of the input circuit. The meaning is small input signal change may get in the output is a large change, appreciable change, that is called as a strengthening the signal. The meaning that this DC voltage will enter into the signal and the signal will strengthen. So this is the amplification property. As we know, as IC alpha IE similar variations occurs in the IC, the varying IC passes through the larger load resistor RL and a large output voltage is developed across it. The change in output voltage is mainly or many times greater than the change in the input signal voltage. The meaning is whatever the change in the input signal in the output is many times greater than the input signal. In this way, a weak signal applied in the input circuit appear in the amplified form in the output circuit. That is the meaning. If we apply the weak signal in the input circuit, that weak signal amplified in the output circuit. That weak signal amplified in the output circuit. So what is the now we try to discuss. This is a simple introduction about the amplification of the circuit. Now we try to discuss different configurations we need to know how we can connect and all those things we try to discuss now. So my objective is to complete after completion of this topic we need to understand three transistor configurations. So an amplifier is a 4-terminal circuit, 2 terminals 1 and 1 dash from the input port and the other 2 and 2 from the output port. And the transistor having the 4 terminals we having. So like this amplifier 1 dash 2 dash we need to have. So we need to get these 4 terminals from our transistor. To the input terminals we connect a signal source Vs, that is microphone changes sound waves into a weak electrical signal. A load R2, a loudspeaker which changes the electrical signal into the sound signal, is connected across the output terminals. An amplified output signal V0 is developed across the R2. Thus, an amplifier is a 2-port 4-terminal circuit, whereas a transistor is a 3-terminal device. You know the 3 terminals: emitter, base and collector. So now we try to understand, do you know how to make a 2-port circuit with a 3 terminals? Yes, that is the way. That is, we have to make one of the 3 terminals common for both the input and output. One of the terminal common for both the input and output. This common terminal is normally grounded. So now following are the 3 possible configurations of modes in which a transistor can be connected in amplifier. The thing is, transistor will be connected in 3 ways. The first one is the common base, second one is the common emitter, and third one is the common collector. That is, base is common and put in the ground, emitter is common and put in the ground, collector is common, put in the ground. So common base configuration, you can see the diagram: emitter, base, collector. Here we use the NPN transistor that indicated by the arrow. The arrow is going from the P to N. That is the NPN transistor. So this side is we make the base for the base is common for input and output. This is the input and this side is the output. Input and output. The next one is the common emitter configuration. You see here, common emitter. Emitter is made as a common for both input and output. Emitter, here we making the common for input and output. So input is connected across the base and emitter. Output is taken from the collector and emitter. This is called as a common emitter configuration. The next one is the common collector configuration. Common collector is common for both the input and output. So the input is given to the base and collector terminals. Output is taken from the emitter and collector. So these are the 3 different configuration. So now we need to understand what type of characteristics these 3 configuration processing and what characteristics are useful to make the transistor as an amplifier. So we now try to discuss them. In a figure, the transistor is connected in the common base configuration. The input signal is fed between emitter and base. The output signal is developed between collector and base. Thus, in common base configuration, base is common to the input and output. In the common emitter configuration, the base is the input terminal and the collector is the output terminal. Emitter is made common to the input and output. In the common collector configuration, input signal is fed between the base and the collector. The output appears across the emitter and the collector. Collector is common to the input and output. It should be remembered that regardless the circuit configuration, the emitter is always forward biased and the collector is reverse biased. That is main thing we need to remember. The transistor always operated in the active region. That is nothing but the emitter junction is forward bias, collector junction is reverse bias. Now we try to discuss about the transistor static characteristics. So what are the different we having the characteristics in the common base, common collector and common emitter. So what is the characteristics means? Characteristics gives the behavior of the device. So how it is behaving for applying DC voltage. So the meaning is how much it offering the input resistance, output resistance, and where it is on, where it is off, and so on is given by the characteristics of the device. So our device can be connected in three ways, that is the common base, common emitter, common collector, in three ways. So these three ways we need to study in which way is more useful for us, in which configuration we can get the more advantages we need to discuss. So that we need to study the characteristics of the device. So now we try to discuss about the input characteristics of transistor in common base configuration. So common base configuration, we try to discuss the characteristics. Transistor static characteristics. These are the curves which represent relationship between different DC currents and voltages of a transistor. So what is the characteristics? Characteristics are the curves which represent the relationship between different DC currents and the voltages of a transistor. These characteristics are helpful in studying the operation of a transistor when connected in a circuit. So how you know the operation of the circuit, how you know the operation of the transistor, it depends on the characteristics. We can know that operation of the device by studying the characteristics of the device. The three important characteristics of the transistors are input characteristics, output characteristics, and third one is the current transfer characteristics. Input characteristics, output characteristics, current transfer characteristics. These characteristics for the three configuration, common emitter, common base, common collector, we need to study. Okay, now we go for the now let us discuss about the input characteristics of a transistor in common base configuration. So in the common base, how? First of all, we need to know common base. Base is common. The input is the emitter base, output is the collector base. Okay, so emitter base, collector base is there. We try to find the input characteristics. What are the input characteristics? The input characteristics curve gives the relationship between the input current, that is emitter current, and the input voltage, that is emitter to base voltage. Emitter current, emitter to base voltage for a constant output voltage, that is the output voltage is the collector base voltage for the constant collector base. The meaning is, in order to study the input behavior, we need to make the output constant, so that whatever the change occurred in the input side, that is because of our applied voltage change. Otherwise it may influenced by the output voltage. So that's why we make the output constant. The relation, that is the common base configuration input characteristics curve, gives the relation between the relation between the emitter current and the emitter to base voltage when the collector to base voltage is constant. These curves also known as base curves for the transistor. Base curves for the transistor. These characteristics may be obtained by means of a circuit arrangement as shown in the figure. You can see the figure how it is. Common base is there. What we need to do here, what we needed is we need the voltage regulator, two voltage regulators, two ammeters, two voltmeters we need. So common base input characteristics means we need to have the IE and VBE. We need to know the IE and VBE, and making the VCB is constant. VCB is constant. So by using this VCC, we make the V constant. That is the VCB constant. After making the VCB constant, we need to change the VEE. If you change the VEE, this left side VEE, what happens? The ammeter and voltage meter values are changes. The graph between the VBE and IE, the graph between the VBE and IE when VCB is constant is called as the common base input characteristics curve. So by using this diagram, by using this circuit, we can take the values of the VBE and IE. So in this figure, the NPN transistor is connected in CB configuration. So collector to base voltage VCB can be varied by changing the position of the potentiometer of R2, while the emitter to base voltage can be varied by changing the position of the emitter R1. So the thing is, we can vary VCB and VCE. So the DC milliammeters and DC voltmeters are connected in the emitter and collector circuits of a transistor to measure the currents and voltage. It shows how IE varies with the VBE when voltage VCB is held constant. It shows IE varies with VBE voltage when VBE is held constant. First voltage VCB is adjusted to suitable value with the help of the potentiometer R2. What we need to do? First voltage VCB is adjusted. First voltage VCB is adjusted to suitable value with the help of potentiometer R2. Next, voltage VBE is increased in a number of discrete steps. Step by step, we need to increase the VBE, and by varying the supply VEE and varying the supply VEE, corresponding value of IE are noted from the milliammeter connected in the circuit, in the emitter circuit. So what we need to do is, by using the VCC, we need to make the VCB is fixed at a particular voltage. After putting the VCB at a fixed value, coming to the input side, now we need to vary the VEE and measure the values in the VCE, that is the VBE and IE. So these two values gives the. Thus, the same procedure was repeated for different but constant VCB. For once VCB, one type of readings. Like that, for different VCB values, we need to take. So when plotted, we get the input characteristics as shown in the figure. One for the germanium and other for the silicon. You can see input characteristics how it is. Just like the PN junction diode, germanium and silicon, already we know the germanium having the 0.3, silicon has the 0.7. So but because of the input output voltages, it is not a pure diode. So we having the two characteristics, that is the IE versus VBE. IE versus VBE. When VBC is constant. When VBC is constant. Now we try to know static resistance or something. Input side represents as a PN diode and is forward bias. That is emitter junction is forward bias. Already we know that always emitter junction should be in forward bias. Emitter junction should be in forward bias. So input side represents a PN diode and is forward biased. Emitter junction is forward biased. Therefore, input characteristics of common base transistor is similar to diodes forward bias characteristics. We can simply say that input characteristics of the common base transistor is similar to diode forward biased characteristics. It is clear from the input characteristics as VBE increases, IE increases. VBE increases, IE increases, that is voltage increases, current increases slowly, non-linearly till the VBE has reached its junction cut-in voltage, V gamma. Once VBE voltage is greater than V gamma, IE is increases linearly and rapidly with a small increase in the VBE. If the small increase in the VBE, the IE increases rapidly just like the PN junction diode until the VBE reaches the V gamma, that is cut-in voltage of the junction. It produces the small amount of IE. After reaching the V gamma, a small change in the VBE may produce the larger change in the IE, larger change in the emitter current. From these input characteristics, the dynamic input resistance of the transistor can be calculated by dynamic resistance is delta VBE by delta IE when VCB is constant. The value of dynamic resistance is very low, 2200 ohm. You can see the input characteristics already we've seen. Emitter to base, that is the emitter current. So we take the dynamic resistance. You can see the dynamic resistance delta VBE by delta E. By taking the two values from the input characteristics, we can calculate the dynamic resistance. Dynamic resistance value, that is the delta VBE by delta IE. The value when the VCB is constant, generally the value is very low, 2200 ohms. 2200 ohms, you can see. So this once again you can see the input characteristics for the different VCBs. VCB value 1 volt, VCB value 5 volts, VCB value 10 volt. What happens? Slowly the curve bending is going to straighten. The curve going over to straightening that one. Okay. From the figure it is clear that IE increases with increasing the output voltage VCB. IE increases. What is the meaning? IE value increases fastly when the VCB value, that is the constant value, increases here. At the 1 volt after 0.7 it is increasing. At 5 volts is here, before 0.6 it is increasing. At 10 volts before 5 only it is increasing the maximum value. So that is from the figure it is clearly shows that IE increases with increasing in output voltage VCB. The curve shifts upwards by increasing the VCB. This occurs because of the phenomena called base width modulation or early effect. So why we are getting this type of increasing means this occurs because of the base width modulation or early effect of the device. We need to know the base width modulation. What is the base width modulation or early effect? As the output voltage VCB increases, that is, as the reverse bias on collector junction increases. Reverse bias on the collector junction increases, the depletion layer at collector junction is increases. What happens at the collector junction? VCB increases means reverse bias is increasing. Collector junction is increasing. This depletion layer penetrates deeper into the base. This depletion layer penetrates deeper into the base, reducing the effective base width and the resistance between the emitter base and the collector base region, so that there is a slight increasing in IE, slight increasing in IE. So that's why it is called base width modulation. The meaning is base width is modulated because of this increasing in the reverse bias at the collector junction. Reverse bias at the collector junction. So now we try to discuss about the output characteristics of a transistor in common base configuration. So until we discussed about the input characteristics of the common base, the input characteristics of the common base is similar to the PN junction diode forward bias characteristics. As the common base increases, as the common base voltage increases, the emitter current is increases as early as possible. So because why we are getting this type of increasing means because of base width modulation. What is the base width modulation or early effect means? When the common base in the common base collector to base reverse bias voltage increases, junction goes into the more and more reverse bias. So what happened means more and more reverse bias means the depletion layer more and more depleted into the base region. Already base is a very thin region, so if the depletion layer slowly enters into the base region, so what happens means it reduces the width between the collector and the emitter. So fastly we can get the more amount of currents. That's why it is called as a early effect. Now we try to discuss about the output characteristics of the common base emitter. So once again we try to discuss. In the previous we discussed the input characteristics of a transistor in the common base configuration, how the characteristics varying with increasing in VCB. With the help of the same circuit arrangement, we will discuss the output characteristics in this class. To determine the resistance from input characteristics, set up to obtain output characteristics of a transistor in common base configuration as shown in figure. So this is already shown in the input characteristics. Same circuit can be used for studying the output characteristics of the transistor. You can see. So how we can get this one? The first what we need to do is it shows the way IC output current varies with the VCB output voltage when the input current is kept constant. So what are the characteristics of output characteristics means this is the curve between the IC and VCB when IE is constant, that is output voltage and output current graph when input current is constant. So now how we can get the experimental procedure, we try to see. First the input current IE is adjusted to 0. The input current IE is adjusted to 0 and kept constant. Then by increasing the collector to base voltage VCB by increasing VCC from 0 in a number of steps and corresponding collector current IC, that flows is noted. Next VCB is reduced back to 0 VCB is reduced back to 0, IE is increased to a value little higher than before and kept constant. So next readings are making the VCB 0 and making the IE higher, somewhat higher than last value and kept constant. The whole procedure is repeated. The graphs are plotted by taking the VCB on x-axis and IC on y-axis. The family of curves thus obtained are output characteristics of common base transistor. So what we are doing is first, once again we try to discuss in the output characteristics. What we are doing is first the input current IE is adjusted to 0 and kept constant. Then by increasing the collector to base voltage VCB from 0 in number of steps and corresponding collector current IC. So after that, next VCB is reduced back to 0 and IE is increased to a value little higher than the before value and kept constant. The whole procedure is repeated. The graphs are plotted by taking the VCB on x-axis and IC on y-axis. The family of curves thus obtained are output characteristics of common base transistor are shown in figure 2. You can see the output characteristic figure how it is. So in the output characteristics we need to differentiate and know the regions, active region, cutoff region, saturation region. Like this you see here, this side is the VCB and y-axis is the IC when the IE is constant. First making 0, తర్వాత 2 milliamps, after 4 milliamps, after 6 milliamps, after 8 milliamps. Like that we make the different values. IE is 0, then there are no injected carriers in the base. Therefore, no injected carriers current in the collector junction. But a small amount of leakage current ICBO at collector junction will flow due to thermally generated carriers in the base and collector. Thus, ICO is also called collector reverse saturation current. ICO is also called as collector reverse saturation current. If VE increased, IE increases, keeping IE constant. If VCB is increased, the increment in IC will be nominal. It is clear from the family of output characteristics curves that they are parallel, that is, IC is less dependent on VCB, whereas it is much dependent on IE. The meaning is IE affects the IC, but VCB does not affect mostly not affect the IC. So this is about the output characteristics of this one. Now we try to discuss about the three configure regions in the characteristics of the common base transistor: the active region of a transistor, saturation region of a transistor, cutoff region of a transistor. Already we discussed. We need to discuss these three. So this is a common base configuration. So this is the output characteristics of the transistor. You can see. So below IE is 0, that is given as the cutoff region. Above IE equal to 8 milliamps taken as a saturation, that is the saturation is here 0 to -2. So that is the VCB value minus 0 to 0 value, that is called as a saturation region. So what we can observe the three regions in the output characteristics: active region, saturation region, cutoff region. So as we know that every configuration having the three regions: active region, saturation region and cutoff region. So what is active region? In this region, the curves are almost flat. IC is constant and slightly less than the IE. It means IC is practically independent of VCB. IC is practically independent of VCB. Second one is the saturation. In this region, VCB is negative for NPN transistor, that is, collector junction also becomes forward bias. Collector junction also becomes the forward bias, that is called as a collector junction forward bias, emitter junction forward bias. So that is called as a saturation region. That's why we are getting these characteristics in the negative region. In this region, IC does not depend much upon the emitter current IE. A small change in the VCB result in large value of collector current. A small change in the VCB result in the large change value in the collector current. The last one is the cutoff region. The collector current IC is not zero when IE equal to 0. This called the reverse leakage current. The meaning is whenever we are not applying the IE current, then also we having some amount of current is there. This is called the reverse leakage current. The region below this curve corresponding to IE equal to 0 is called the cutoff region. Cutoff region. This is called as a cutoff region. So these are the three regions which we discussed from the output characteristics of the common base transistor. So in the output, what we discussed is in the output emitter current, the input current is constant, and draw the graph between the collector current and the collector to base voltage. So that graph gives the output characteristics. Output characteristics are divided into three regions, that is the active region, saturation region, and another one is the cutoff region. In the cutoff region, the IC curves are constant. So these are practically independent of VCB. After some value, if IE depending on the IE value, automatically we can get the IC value. In the saturation region means the collector current, the collector junction goes to reverse bias when we apply the negative voltage to the collector junction minus VCB. When it is a negative, so this region is called as the saturation region. Small change in the VCB, it will give the larger changes in the collector current. The last one is the cutoff region. The cutoff region is nothing but the off condition. So below, that is the IE equal to 0, below this region is called as the cutoff region because there is no flow of the current. So this is about the common base configuration, input and output characteristics. In the next class, we try to discuss some more things about the transistor configuration. Thank you.